From the beautiful South Studios of Way Happy, this is Mr. Meyer and 10.2 circles. Now let's talk some circles. Circles are the set of all points that are a fixed distance away from another point called the center. So you have a center, and then if you measure a distance and you mark all the points in that distance, that's called a circle. Probably your favorite and nicest shape that we will run into. Now, what do you need to know? You need to know the equation of a circle, which you can see right here on this form. There's the equation. It's x minus h squared plus y minus k squared equals r squared. H and k are the center of your circle. Notice the addition in between the two. So hk is your center and r is your radius. So be careful. This will always be equal to the radius squared, not equal to the radius. So that's always something that some people might trip over. The equation then is kind of generic. You see an example there next to it. You see a drawing of the graph even next to that. So that is how I make an equation of a circle. So I might even want to here show you using the distance formula how this was created. So you can kind of see the distance formula creating this equation that we have. So we know that the distance is x2 minus x1 squared plus y2 minus y1 squared, which is really just the Pythagorean theorem. That would be equal to d squared, right? Pythagorean theorem, that's a squared, b squared, c squared. So now that we do it in distance formula, we use some points, and then we square root this bad boy. So we get rid of the squared. We call this a square root of this distance. That's a nice straight line. And then from there, I go ahead and I can go, all right, now let's find it using this. Well, we know the distance for this, right? We know it's 6. So I can put 6 here, and I know the center, we'll call that 0.2, I guess. That would be, let's call it 0.1. X minus 3 squared plus y minus 4 squared equals 6. And then how would you solve that? Well, you have a radical there, so you'd square both sides. So you'd get 6 squared, or 36 is equal to x minus 3 squared plus y minus 4 squared. And you say, wait a minute, that's the equation of a circle whose center is at 3, 4, and the distance is 6. So that's how this fancy formula was created. It was created just by using distance formula and the understanding that a circle is the distance, it has a fixed distance from a center. That's all it is. How would I graph this, by the way, if you're curious? Here's my graph paper. I would plot the center, which is 1, 2, 3, 1, 2, 3, 4. There's my dot. And then what I do is I go 6 units out. So I'm going to go down 6. I'm going to go right 6. I'm going to go left 6. I'm going to go up 6. And then I'm going to make what attempts to be a nice circle. And everybody goes, ooh, nice. Good. All right, let's try another one. How about these two? You have to write the equation. I give you the center and the radius. Could you make the equation? That's a straight plug and chug. So yes, you can do that. Remember, the formula is x minus h squared plus y minus k squared equals r squared. Clean it up a little bit. X squared plus y minus 6 squared equals 1. There is your equation. That is a nice, pretty equation. Yes, you could FOIL out the y minus 6, but that would be bad because I wouldn't know where the center is anymore, and that wouldn't be helpful. It would just look more confusing, and we will do that, and we'll have to undo that in later sections. What about if I give you this, the center given that circle and goes through that point? So again, knowing the center, I'm excited because I'm like, oh, this is just x plus 4 squared equals plus y minus 11 squared. So there's the center equals, r squared. They didn't give us r, but what did they give us? 2 points. We know that point's on the circle, 5 1's on the circle. So I could figure out that distance and get what we call the radius. So real quick, I gotta be like, all right, r equals the distance, right? Equals, it doesn't matter which way you go, 5 minus a negative 4, so 5 plus 4 squared plus, what did I do, 5? So now it matters. I got to be in the same order. Negative 1 minus 11 squared. And so I got, these are big numbers. 9 squared plus negative 12 squared. Cool thing about squaring is it'll get rid of any crazy fractions we had, or any negatives we had, not fractions, plus 144. little perturbed because I almost burned down the house here with a sparking power cord. 81 plus 144, what is that? 8, 9, 10, 11, 12, 225. Yeah, I think that's 225. So that's the square root of 225, or what most people would call 15. Oh, so r is 15. Oh, wait, darn it. I needed r squared, so I needed 225. So x plus 4 plus y minus 11 equals 225. And there you go. There's the equation, who has a center -4, 11, and has a radius of 15, which I had to calculate by using the other point and my understanding of what a circle's definition is. All right, let me ask you a question, and I'll see you in a minute. All right, nice work. Now, let's go on example 3, something that might be realistic. We're trying to find out which homes are within a 4-mile location of a tower, a cell tower that we put up, say. And so we've mapped it all out, and we got an overhead Google Sites view of what this place looks like. And we put our cell tower at 1, 1. So the cell tower is sitting, I don't know, can I get it on there? 1, 1. I tried to do a black dot. I don't know if you can see it, but there it is. Highlighting yellow doesn't work. So there's the black dot that our cell tower is at. And we want to know if it's within 4 miles. So 4 miles in every direction. That's awesome because that's a circle. So from that, I'm going to go up 1, 2, 3, 4. And I'm going to go right 1, 2, 3, 4. And you're going to see me go down 1, 2, 3, 4. Hey, I know E is covered. And left 1, 2, 3, 4. And that's, the corners of my circle. And so now I'm going to do my best to try to draw a circle, which we've seen my drawings. Yeah. All right. What do you think? I'm feeling pretty good about, I know A is in, B is in, C is in, E is in. I can't tell what this random dot is here. I don't know what letter you are. F is definitely out. So for sure the in group here, I can write who's in. I know it's A and B and C, and let's see, E is there. That rogue dot, I don't know who you are. Who is definitely out is our good friend F. They don't get any cell service. The one I'm worried about is right here. I can't tell. Is that, it's got to be D, right? That's got to be D. He's the only one I'm not sure about. Everyone else, I'm feeling pretty confident. Compass would have been, or what is that thing called? Yeah, compass. That thing would have been nice, but I don't have that. So not 100% sure. So I'm going to plug D in. I'm going to get its coordinates. What is that? -2, 1, 2, 3. So D is at -2, 3. And I'm just going to plug it in and see if it works. Now, what am I going to plug it into? Oh, we got to make an equation. X minus 1 squared plus y minus 1 squared equals 16. So if the left side is going to be less than 16, we're golden, right? If it's equal to 16, I think we're going to be okay. And if it's over 16, we're not going to be okay. So here we go. I'm going to plug in that point, -2, 3. So -2 minus 3 squared plus 3 minus 1 squared. Is that, I should have a less than, but is that less than 16? So question mark, I don't know. This would be 5 squared, or -5 squared if you care, plus, what is that, 2 squared? No, I think we're in trouble. Is less than 16. So what I got, 25 plus 4. Is that less than 29? Where did that 3 come from? Are you screaming at me right now, I hope? Notice my brilliant math. I had a -1 here, and I did x minus 3. Yeah, it's one of those days. So I'm like, why is this so not close? I should have been able to tell if that was that bad. And so here we go. This is going to be a -1, yeah, and this is going to be a -3, and this is going to be a 9. Oh, this is looking a whole lot better. It's actually looking close. Is 13 less than or equal to, I should have said 16. It is. So guess what? That family, they are actually inside the arc. So they are happier. So maybe you want to check F. Maybe F is making you wonder. So plug it into the equation and see, if you're not 100% sure. And I'm feeling pretty good that I know. And so I'm going to say D. You guys can also be in the people that get service. So now I can tell AT&T or Verizon or whoever, yeah, this is a good spot for a cell tower. We're going to get most of them. Those people at the F, they're going to have to go somewhere else. Good? All right, what about number 4? Write an equation of the line tangent. Oh, that's a good challenge. This is one of those thinking ones, right? Think of what this drawing looks like, first of all. So here it is, and it's centered at 0, 0, because there's nothing inside parentheses, so that's cool. Root 29, that's what, a little over 5, because that would be 25, and 36 would be 6, so it's closer to 5 probably than it is 6. 1, 2, 3, 4, 5. So it's like right here, and 1, 2, 3, 4, 5 right here, and I'd have another one here and another one here. It's just kind of a sketch for me. And there's my amazing circle that people love. And they say, write the equation tangent to 2, 5. So 2, 5 is sitting right here. So here's 2, 5. And the tangent line means a line that's just going to touch at that point. So it's got to be a line, a straight line. And it's got to touch just at that point. So it's going to look something like bink, like that. It's going to look like that. And calculus loves define the tangent line because in physics, it can tell you how fast something's going or whatever. It can represent speed, and that's really cool in physics. But right now, we're just going to talk about, hey, a tangent line, right? It just goes over there, kisses that one spot. What is the equation of that line? So it's a line. It should be in y equals mx plus b, or maybe some other form. But that's what I want to know. That's the question. All right, well, do I know anything? Well, good news is this. You have this, I could figure out that slope, and the tangent line is always perpendicular to that slope. So if I know the slope of, what do you want to call this? Let's call this slope 1. If I want to know the slope 1, then what I'm going to do is do y2 minus y1 over x2 minus x1, our favorite rise over run formula. So what is that? That's 5 minus 0 over 2 minus 0. That's 5 over 2. So that's a rise 5, run 2 slope. So guess what? This guy, we'll call him M2. Then M2's slope has to be the opposite reciprocal, perpendicular. So negative 2/5. And I know which point it's got to go through. So your good friend y minus y1 equals mx minus x1, or whatever you use to make an equation, will work here. I'm going to do y minus 5 equals negative 2/5 x minus 2. Now that's usually nice. I think when you get to pre-calc, I would let you stay there. But right now, I want you to work on your algebra skills. So distribute that negative 2/5 through, if you like, negative 2/5 x plus, what is that, 4/5? And then something that will give everyone nightmares, add 5 to both sides. Negative 2/5 x plus 4/5 plus a 5. Oh no, I can't add a 5 because I need to get these two constants right here. They need to be added together. So, all right, let's change 5 to 25/5 if you don't mind. And we have an answer. Y equals negative 2/5 x plus 29/5. Lo and behold, we have the equation of the line that is tangent at that particular point. The slope would represent like the speed, if you were curious about that physics comment. The slope would represent like the speed, 0.4, negative 0.4 miles an hour or something. Awesome. You guys have a great day. Stay happy, and I'll see you tomorrow.